Okay, so we're at the second objective of section 1.5, the limit of a function. This objective is that the student will be able to understand one-sided one-sided limits. Here's a function h. It's 0 for negative input values, 1 for non-negative input values. H of t approaches 0 as t approaches 0 from the left, and h of t approaches 1 as t approaches 0 from the right. So on the right, it's 1, and on the left, it's 0. We indicate this situation symbolically by writing the limit as t goes to 0 from the left with a little negative symbol looks like it's in an exponent. Limit as t approaches 0 from the left of h of t equals 0, and the limit as t approaches 0 from the right of h of t equals 1. Okay. The symbol t going to 0 from the left with the negative looking, an exponent looking thing, which is a minus sign, indicates that we consider only values of t that are to the left, less than 0. And if we've got the plus sign, that indicates that we only consider values of t that are greater than 0. Of course, it indicates more than that, right? If you've got this plus sign here, yeah, we're only looking at the right, but there's a direction to it, right? It's going right to left, even though we're considering values on the right. And you know, what we're talking about is, okay, on the left, we've got this graph. But on the right, we've got this. And so there's a direction to it, right? T, this is the t-axis here, t is approaching 0 from the left. From the right. If you've got the plus sign right there. So definition of one-sided limit, again an informal one, relatively informal. We write the limit as x approaches a from the left of f of x equals a number L, and say the left-hand limit of f of x as x approaches a, or as I say it, the limit of f of x as x approaches a from the left. Actually, what I say, the limit as x approaches a from the left of f of x equals a number L is equal to L if we can make the values of f of x arbitrarily close to L, as close as we like, by taking x to be sufficiently close to a and x less than a. So x has to be less than a, but it's sufficiently close to a that we make f of x arbitrarily close to L. Notice that definition 2 differs from definition 1 only in that we require x to be less than a. Similarly, if we require that x be greater than a, we get the right-hand limit of f of x as x approaches a is equal to L. And we write the equation with the plus sign. Thus the symbol x approaches a from the right with the plus sign means that we consider only x greater than a. And of course there's a direction toward the number a. These definitions are illustrated in figure 9. Okay, so x is approaching a, and then maybe if x is approaching a from the right, then x is over here, and a is over here, and we're moving in this direction as opposed to this direction. By comparing definition 1, which is just the definition of a limit, with the definitions of the one-sided limits, we see that the following is true. Very important rule, extremely important. You dare not fail to remember it. I don't think you will fail to remember it. You've got a limit, just a plain old limit as x goes to a of f of x equals L, if and only if, okay, each side determines the other, if and only if the limit as x approaches a from the left of f of x equals L and the limit as x approaches a from the right of f of x equals L. If one of those two things is not the case, then you don't have a limit. You might have a one-sided limit, but you don't have a limit. The graph of a function g is shown in figure 10. Use it to state the values if they exist of the following. So here's a drill, 6 little problems, and I encourage you to pause the video and come up with 6 answers. Okay, for A, they're asking for the limit as x approaches 2 from the left of g of x. Okay, so x is approaching 2 from the left, and this limit, here's y equals g of x. Okay, well, as x approaches 2 from the left, this function g of x, it's getting greater and greater and greater and greater, and it is approaching 3. It's approaching 3. So as x goes to 2, g of x goes to 3, and that's the limit. That's a left-handed limit. Part B, what about as x approaches 2 from the right? Well, as x comes from the right, from the bigger numbers, greater numbers, toward 2, g of x is actually decreasing to 1. Because the point 2, 1, well, it's not on the graph, but the endpoint is there, which that is where the endpoint is, even though the graph does not contain the endpoint. So this is 1. C, limit as x approaches 2 of g of x. Well, we just said if a limit, not a left-hand limit, not a right-hand limit, just a limit. It's not 2 with a negative sign in the exponent. It's not 2 with a positive sign in the exponent. It's just 2. If that's going to exist, that exists if and only if the left-hand limit exists and the right-hand limit exist, and they both have to be L, but they're not both L. They're different numbers. The answers to A and B are different. So this limit does not exist. Okay, there just is not a limit. You just can't talk about a limit like that, only as one-sided limit. Now 5, you can see something interesting has happened at x equals 5, kind of similar in a way, but in another way not. The limit as x approaches 5 from the left, well, as x approaches 5 from the left, g of x looks like it's going to 2. Okay, so 2. And same is true as x approaches 5 from the right. That's going to 2 also. Now remember, not x equal to 5, x approaching 5. When x equals 5, g of x looks like it's 1 point something. Or maybe it's just 1. But it's not 2. But these one-sided limits, and also just the regular limit as x approaches 5, x is not equal to 5. We don't care about x equals 5. We only want to know what happens when x is approaching 5. And when x is approaching 5, this limit does exist, and it's 2. Okay, so again, the left-hand limit as we approach 2 from the left is 3, but from the right it's merely 1. Therefore, the regular limit as x approaches 2 of g of x does not exist. But at 5, they're both 2, so the limit does exist, and it's 2. Despite this fact, notice that g of 5 is not equal to 2. G of 5 is 1, or something slightly higher than 1, something slightly greater than 1. But it doesn't matter. The limit as x approaches 5 of g of x equals 2.